Okay, so we were last time discussing this slide about regular expressions. Now we're going to use regular expressions with grep. Let me change this to view present. And well, first of all, before we get to grep, which is the main use, notice grep is called global regular expressions and print. But before we get there, it's built for regular expressions. Let's do find. Now, find is a nice little program to find files. It has lots of extensions, lots of flags, and you can do a lot of things with it. Let's do the simplest example. If you do find dot, it's going to be like you did ls. It's going to give you all of the files in the directory. Dot meaning the current directory. The only difference is that it will also open up all the subdirectories and all of their subdirectories forever. So you'll find a lot of information. You'll find all the files and everything in your subdirectories and everything in their subdirectories. That's nice. So you'll find everything. If you would do, for example, find dot and you happen to be in the root directory / you would see every single file on the computer. So it would take you a long time to print it all. You can also do, so here I changed the example to be with a / as though I'm doing from the top. And then I'm saying -name. And that means the file's name should be Fred. So I'm looking for any file named Fred. Now I may want to have a file that starts Fred, in which case I would write Fred star using file globbing rules. But I have to put it in quotes so that the shell won't try to expand it. Can anybody tell me what would happen if I didn't use quotes here?
Double quotes, if we did.
I didn't use double quotes at all. I just wrote Fred star. What would happen is the shell would try to expand Fred. It would look for etc files in etc that has start Fred, and if there aren't any, it would have nothing here, and I'd be like finding it, and it would tell me find would then get nothing over here and say name requires a parameter, and I'll say wait, I don't understand, but I gave it a parameter Fred. But it won't really have a parameter because the shell will have turned Fred into the list of files that are in etc, and there aren't any, so it wouldn't find it. Now, you can say, well, if there aren't any in Fred, in etc, why am I looking for it? Well, it could be that in etc, there's another directory and another directory in that, and in that, and in that, and somewhere down the road, there's a Fred file that starts Fred, and I want to look for that. So then I'm going to have to use quotes, and I'm telling it, no, it's a parameter for find is the Fred. Don't, Mr. Shell, please ignore, do not try to expand, do not try to do file globbing on Fred star. If you didn't understand, it's not important. But if you understood, then I've explained something that many people do not quite understand. Find etc minus type D is directory. If it's a directory and its name is home or anything starting with home, then I'm going to find it. But of course, again, I'm looking only in directory etc. It's kind of dumb to look in etc. It's probably not there. I should probably have written / there, but I'm just showing you the examples that I can specify a directory or even a named directory, not only / and dot. All right, that's it for find. I mean, find has other parameters, has millions of things. You could spend a month learning find. You can even execute commands on the files that I found in find. Find has its own flags for executing, but I'm not going to teach you that now, or I'm not going to teach you that. So now we're on to grep. And the next couple slides are grep. Grep is global regular expression and print. Search within files and for strings matching regular expressions, print those lines. So we're going to search inside of files any line that matches what we're looking for, and it'll extract those lines and print them to the screen. So I'll get to see the lines that have what I'm looking for in them. Now you see all these functions like find and grep and other things that we learned. They were added to the Unix once it was written. Unix was written, and then they started needing to check files and to look for places. They said, I would really like a program that could quickly give me lines from files based on patterns. So Ken Thompson wrote Grep. There's an interview with Ken Thompson on Wiki on the Moodle. I suggest you watch it. It's it's a slow lecture, but it's not a TED talk, but it's reminiscings of this guy about how he developed Unix. It has interesting stories, anecdotes, and I put it there for you to look at. Ken Thompson. Now, Grep minus V is the invert match. Minus I is case insensitive. Normally, Grep is case sensitive. Minus C, only print the count of matching lines. In other words, how many lines did I find that had that in it? Don't even print me the lines, just the count. So here, for example, Grep hello world with a minus I means look for hello world or even capital hello world in the file and extract and print to the screen any lines that do have hello world in them. Grep minus I could also do without quotations, but then I would have to put a backslash before the space because otherwise it'll think that I'm grepping for hello and then looking in a file named world. But I want to say, no, this is one long string, hello world. So I have to backslash the space, or I can use quotes. Also, I can use a dot here, like a regular expression. Dot. What does a dot mean in regular expressions? You remember?
This
Quick.
This directory or whatever.
No, that's this. That's in the shell. What does it mean in regular expressions? We just learned regular expressions. It's in bold on this slide.
Matches any single character.
Yes. So this dot here, except here, this dot here means it'll match for world, but it also match for wood. Hello wood would also match. Now, if I can also do grep noop ack file. Find noop or ack in file. So I can use the or symbol to indicate, look for either word. But I have to backslash it because otherwise it'll think, what will it think if I don't backslash it? Can anybody tell me?
Just that entire word with the bar.
Exactly. It'll think I'm actually interested in that word with the bar. Hey, is Avraham here today? Yeah, okay. Yeah.
I'm here.
Okay. Now we're at grep versus egrep. Now I guarantee you, Avraham, I mean, I don't guarantee, I think I can guarantee you that there's some things here you did not know, but
no,
we'll
I
see.
don't use egrep.
You knew up till now, but we're gonna tell me if we get to something that you didn't know. I don't think you're gonna know everything here.
I don't know egrep.
What?
I don't know egrep.
There you go. Oh, so we're gonna learn about egrep, extended grep. So in egrep, these symbols are treated as meta characters, whereas in grep, they are rather treated as part of the pattern. So for example, like we saw in the previous thing, I had to, this vertical line, which is or, is treated as a regular character. I had to backslash it to tell grep, this is not the character vertical line, this is the meaning or. I had to backslash it. In egrep, I don't have to do that. That's basically the point. See the vertical line here and also these other ones. So for example, ls grep, this means .text.php. So he's saying in the files, I'm listing the files, and then I'm going to grep in those files. It's kind of a dumb thing to do what I did here, but because I could have just written star over here, it would have been the same pretty much. If I had done, instead of this, I could have done grep and this thing, and then a star over here would have been all the files. But I just did ls, and then I did grep, and I'm looking for this. Now, what it's actually going to do is not what I intended. What I intended is any file that has in its name .txt or .php, which means it could be a file called, file.txt. It could also be a file called file.txt.txt. Or file. But it's actually not going to do what I thought. It's going to look for a file with the actual string .txt pipe.php. So egrep, if I were to replace this with egrep instead of grep, I would actually get what I wanted. Egrep understands what I mean. So by including backslash, follow, now now you can ask, how can I actually search for, no, how can I actually search for this symbol in egrep? Well, I'll actually backslash. But by including a backslash followed by a meta character, we can make grep treat these characters as meta characters, like we just did in the previous example. So I could backslash all of these ones, but it gets very confusing. Like you see here, backslash parentheses, backslash this, backslash parentheses. It's kind of annoying. So I can use egrep, or the equivalent is grep with a capital minus E. And that is equivalent to writing egrep, extended grep. So here in this example, I'm using parentheses to indicate groups. So I want the or to work on this group of words, fork or group. So it's going to be like this. What does this line mean? Can anybody explain to me what I'm doing here in this one line? Well, it says here.
I know,
Return
but
the lines.
Isn't the caret going to make it the opposite?
Excellent question. The caret makes it
Well,
opposite
brackets.
only inside of brackets. Here we are not inside of brackets, so it will mean the other thing. It's an anchor. It means beginning of the line. So the line, return lines that start with either no fork or no group. Without the E switch, I would have to backslash everything here. So the E or the E switch or the E grep is just saves me having to backslash stuff. But actually, I can pretty much do the same things with grep. Sometimes things don't work with grep, and then you try egrep and it works because you didn't realize that you forgot to backslash something. You know, just making sure I did everything on this slide. I think so. Now we have more egrep examples or grep examples. So here's an example of grep. And can somebody translate what this line means?
Anything that has a B, not an I or an O, that appears 2 or more times, and then a G.
And then a G. So you might think it will find me something like if this is my file, let's say, it might find me the word bag with 2 A's, because an A is not an I or an O. It's 2 or more times. It might find that for me. But why won't it?
Because you didn't use the E.
Because I didn't use egrep, and because I didn't backslash or I could have backslashed the braces here. Notice the brackets. Do I have to backslash the brackets? Well, it's not in my list here, so apparently no. But I do have the braces to backslash. Now, this one what would this one search for? Well, it's the same, 1 or more times, but in the opposite of not IO, yes IO. So
what is it actually searching for in the second case, let's say?
it's searching for the word big or the word bog.
I thought that's what happens if we put in egrep.
Oh, you're right. It will.
What is it at the moment?
At the moment, it's going to fail. Oh, what is it actually searching for?
That's
Yeah, it might be searching for the actual character braces, B or I or O, followed by a brace, a 1, a comma, a brace, and a G.
So it'll get the first set of square brackets but it won't get the curly brackets.
That's correct. That's correct. So if this is our file, big bag, bog, bag, we get no results. But with egrep, it will give us results. We'll get big and bog here. And here we'll get Also, well, also, exactly, we'll get bag and bag because one or more. And here we'll get, right, one or more of these. And here we'll get bag because we're Dafka want 2. We specifically want 2 or more. So we'll get bag. 2 or more what? 2 or more not I's or O's. What is a not I or O, by the way? In other words,
Can't be both an I and an O.
right, but no, the point is not an I or and not an O. So in other words, a letter A
A, B,
is not an I or an O. But also space is a not I or an O. A number is not I or an O. Even I'll go so far as to say the null string is not an I or an O. So this multiplier becomes kind of weird. Well, anyway, I don't want to get into that. There is such a thing as called the null string. I don't want to talk about it. It's not a good example for it. Let's go on. Nope. That's it. Oh, we're at the end of the slides. That is the end of the slides. Okay, which slides was this? This was 2. So now we're on to 3. And I'm Nachum Danzig. Now we're on to sed. We're going to learn a bunch of utilities that are going to do different things. We already learned tr, which translates letters. We learned cut, which gives you columns of a line. Now we're going to do sed, which is a stream editor. It's a kind of editor, but we're mostly going to use it for switching. You don't have to switch. You can also delete things. It's an editor that works as a filter. In other words, filters as lines come through. I think I talked about filters. So sed is a utility that parses and transforms text. It reads input line by line, applying whatever operation you specified in the command line, and outputs the result of the line after the transformation. And it recognizes regular expressions. That's important to know. So let's say here's our file. Now let's take a minute to look at this file. This is like a snippet of your typical password file. And you have a password file is a file that has like certain account information. It used to contain the encrypted password of the users, but it doesn't anymore because it's the file by its nature needs to be world readable. And it used to be thought that giving people the access to the world readable encrypted password is not dangerous because it's encrypted password. It's very hard to unencrypt it. But now that computers are so powerful, it's easy to unencrypt it. So therefore, now they made the password sit in a different file called the shadow password. And there, that file is only root accessible. And therefore, this file can still be root accessible. But in the field that used to be the password, they put this ampersand, this a pound, and then the username again. This used to be the password field. So that's why it's called the password. So now it's a password file without a password. It's kind of funny. So RELC is the username. This would have been the password, but it's not. This is the user ID number. This is the group ID, whatever group he's in. Notice these two are the same because they're in the same group. These two are in different groups. I mean, these two are different usernames. The usernames, the users are different users. So they have different user numbers, but the groups can be the same. Ariel Cheen is his first name, is his last name, and his home directory is in user u37 stud RELC. And his shell has been T-cell. Notice he's T-shell, he's bash. And the semicolons indicate the new field, like the username ends at the semicolon, then the password. So the semicolon is what we call a field separator, because the field separator could be anything we want, but in a password file, it is a colon. So let's say, well, first of all, yeah, let's say we want to, here's our file again, but let's say we want to switch all these, this RELC with the word Paul, REL to Paul. So we can do that like, we can do that like this. Sed, stream edit, switch, S means switch, switch REL for Paul. In which file? The password file. So now we're going to get Paul, but here our caddy is not REL, so it doesn't change. Now the question is, notice or wonder why RELC here didn't change, REL here didn't change. Should have been all the RELs. It's only the first one per line. So if we wanted to switch all of them, we add a G at the end, global. So it'll globally replace REL with Paul. So we got Paul. This line didn't have an REL, so it doesn't change. Sed can be also used with redirection. Most commands can work like that. Actually, every command, but pretty much, you can either, well, the first example is kind of, that's the main point, that I can switch this, because remember, when I switch this, it just was the output was this. This was the, notice I write the word output. Output is Paul C, Paul D, our caddy, but on all these lines. But the file itself never changed. I just filtered. It just went through a filter and came out the other end like this, but the original file is still unchanged. So if I want to preserve these changes, I have to put them into some new password file. Then later I can do a move, an MV, and change the new password file to password. And then I have a new version of the password file. I can also check if there are changes and what they are by using the command diff that we learned. So as if I'm very nervous that there's a mistake, I can do this command, get my new password file, then do a diff between it and the original password file and see all the differences and make sure they're right. Now that I see they're all right, I can move new password to password and overwrite the old password with the new file. I can do the same thing with adding this other arrow here. What exactly is the difference is not easy to explain, but the basic idea is, but I will explain it. The difference is that here it's taking it as a parameter file. Here it's as though there's no parameter here. It's as though I wrote cat password type sed. I'm sending it as a stream into the sed editor. Here I'm actually just giving it as a parameter to the sed editor. Anyway, both do the same thing. Choose whichever way you prefer to write and write that way. Printing the matched pattern, ampersand. Use ampersand to print, to capture the string that matched the pattern and print it as desired. Here we capture the first numbers in the line and print it twice with the www inserted and then print the rest of the line. So for example, here I did sed with files, but I can actually do sed with any input. So I can, sed, okay. So I can just say echo and have a string here and have the string go into sed. And now sed will perform whatever it wants to perform on these letters and numbers. So sed switch any number 0 to 9, any digit. Notice it says plus 1 or more times. I want Dafka 1 or more times. Star would not work here. 1 or more times. Replace that with what? Well, with this symbol, www, this symbol. So this symbol, which we'll call ampersand, actually symbolizes whatever the match was. So for example, what could match 0 to 9 plus a number of times? Well, 1, 2, 3 could match it, because that's a 0 to 9. And this is 3 times a 0 to 9. This is a 0 to 9, this is 0 to 9, this is 0 to 9. So it matched 3 times. So now I found a match for this. And on this line, I'll replace the 1, 2, 3 with what I wrote over here, which is whatever you found. Well, what matched this that I found? 1, 2, 3. So I'm going to replace it with itself, 1, 2, 3, followed by WW, followed by 1, 2, 3. And that's what you see here. 1, 2, 3, WW, 1, 2, 3. The ampersand is whatever I matched. Okay. Now we can do restrict printing with -n. So this is kind of weird, but you could tell sed not to print anything. Well, that's kind of dumb. Why would you want the sed if it's not going to print anything? Because I can use the P to force printing. What does that mean? I can, in this line, in other words, remember, our original file looks like this: Arcadi, RELC, RELD, and Arcadi. Now, I'm sorry. So this means globally replace any REL followed by something with whatever you found twice. So when it found RELC, remember REL followed by a dot, followed by something. So it found RELC, it replaced it twice, RELC, RELC. As it replaced it with whatever it found, but I wrote whatever it found, whatever it found. So it's going to be twice whatever it found. RELC, RELC, RELChin, RELChin. But it's going to be don't print anything. P means except for the ones that matched. Well, this row matched, RELC and RELD both matched. So it'll print those ones with the replacements. What about the other one that was Arcadi? He won't get printed at all because he wasn't a match, because the -n got rid of him. So essentially the -n gets rid of them. The -p brings back the ones that match. So you've effectively created a version of Grep, kind of like Grep, because now you've searched for REL. If you had only one ampersand here, then you would just replace it with itself, which means it wouldn't change at all. And yet I only printed those ones that matched. So I've made Grep. Actually made Grep with sed. Maybe that's how Grep works with sed. Anyway. You can also remove lines instead of S. You can just search for a pattern and then do a D on it, which means delete, drop any line that ends bash. So here I'm saying sed, search for something that ends bash. Why ends? Because this $sign. $sign means no more letters after this. So that means at the end of the line. So actually, I'm going to drop those lines. So I'm again going to drop Arcadi, because Arcadi, if you remember, was the only one with bash. The other ones had T shell. So I am dropping, wait, here. No. I skipped. So here I'm dropping the lines that do not have a match to the word bash as the end of the line. No, sorry. I'm dropping the ones that match this thing, that match bash, I'm going to drop them. So I dropped Arcadi. Now here we saw you can specify a line number in example 6. So I can say, for example, in the range, let's look at this example, in the range that starts with 2, or actually only on line number 2, replace REL followed by anything with XXX REL followed by anything. So you see, it's only going to work on the second line, and the second line happens to have an Arcadi in it. I mean RELD. It has right REL something. So this is RELD, and it's in that line. So this will work. I'll replace I only do the first one. I didn't do global, but I could have done global. Question. So, question? So I'm substituting Ariel for XXXR. I do this kind of like to close the account because now his username is all screwed up. Of course, it's just the output. So again, this should have worked on RELC, but it didn't because I specified line number 2. We can use the anchor characters. This is called an anchor character, the caret and the dollar, as sole characters in the source pattern to replace the target pattern at that location. For example, I can say replace the beginning of the line with the number 2, and it will add to the first character a prefix 2. In other words, I'm saying the beginning of the line should get a 2. Here I'm saying the end of the line should get a .00. Of course, the end of the line will then be .00, and then it'll be at the end of the line now. But I'm replacing the end of the line with .00, so it's essentially like I'm adding .00 to the end of the line. Okay, sed understands regular expressions, so therefore I can do something like this. Switch from the 6th line to the end. Here the dollar means end of the whole file. What file? Password. Of course, there only are 3 lines in my password file. And then switch anything that starts AR and then is followed by 0 or more a letters or colons, all in lowercase letters or colons. And then followed by what you're going to replace it with. So again, switch AR followed by A to Z or colon, any number of them, with that number, that number, and then what you found with XXX, that whatever you found, which could have been RELZ, and then again XXX. Now, of course, and then G, do it on every instance on the line. Any instance on the line that matches this. Now, you're not going to get any output because the file doesn't have 6 lines. And I wrote 6 there. 6 means the 6th line. Here's another example. Delete any line ending no shell and then substitute away everything after the first colon on the remaining lines. So I can do like this. Sed minus E no shell. So I'm looking for lines that end with the words no shell. And I'm deleting them. But I'm also doing this. It's like and. And I use the E, the minus E before both of them, and it lets me combine commands. I'm also substituting the asterisk, this colon, followed by 1 or more dots. Sorry, 0 or more dots. So either just a colon or a colon followed by, I'm replacing them with nothing. So it'll get rid of, well, what will it get rid of? It'll get rid of a lot, because it'll match anything that's colon, dot, and then anything. Dot can be, when I write 0 or more, when I write dot star, it's like I wrote a star in globbing. So it means it'll match everything. So we're going to match a colon followed by anything and replace with nothing. So what's it going to do? Well, what it's going to do is just give me, the file looks like something like this. The file looks like this. RELC, RLD, Academy. I'm going to replace the first colon that it comes to, followed by anything at any number of times. So it's going to replace the whole line. It's just going to become RELC, RLD, Arcadi D, without anything after, without the colon, without anything after the colon. That's this. Now regex and sed is just like a regex always is greedy, such that what does that mean? That means it was going to use a dot to match up to the last dot, a colon in this line. For example, here in this example, what did I want to do here? I had my password file. It looked like this, and I wanted to replace. What did I want to replace? I wanted to replace something like I wanted to replace, let's say, the first. Remember, it's the first occurrence if I don't write global. So I wanted to replace the first name, dot star, which is anything, until a colon. So that'd be like if it's RELC colon, and then another dot star anything until a colon, which would be like XXX or pound RELC. I wanted to replace those first two with what? With nothing. I want to get rid of them. Well, it's not going to work. What we're going to get is just the last part. It's going to match everything. In other words, I wanted to get rid of RELC and this RELC, and I wanted to have from this number all the way to the end, but it's not going to work. What's it going to do? It's going to match that dot star is going to try to match everything till it gets to this colon. Then the other dot star is going to kick in and do all the way this until this colon. Well, now, why did it stop there? Because it wanted to leave room for the other dot star to have a match. So what I'm actually going to get is everything except the bin slash is going to be disappeared. My match will be this whole line until the last colon, even though I thought it would be just the first two things, because it's greedy. It tries to make the largest possible match it can make. So the largest match it can make is to go all the way to the end. This will be the last colon, then the dot star, then another colon, then the dot star, and all of this. So that's why I'm going to get S bin or whatever, bin bash. What is this? What is Eclipse? Oh, just a second. Okay. So we understand regex and sed. Now another language which you have to use in your homework, awk. I call it awk actually. Most people call it AWK, but awk is shorter, so I call it that. Some people say awk is awkward, but awk is this other language. It's similar to C++ because it was written by Kernighan, who was one of the people who wrote C. It's actually named after three people who wrote it. I don't remember their names, but the K is Kernighan. It's their last initial. It's the first initial. It's the initial of their last names of the three people that wrote it. It came up with this language.
Awk is?
What?
You're saying awk is the initials of their thing?
No, there were three guys. I don't remember their names, but the last one of them is Kernighan.
Aho, Weinberger, and Kermigan.
Kernighan. No, I don't think so. Anyway,
Ah,
the format of awk or AWK is like this: awk, and then minus F is the field separator. What we're going to do with this thing is we're interested in fields of files, like our password file. We want to, let's say, print, just instead of using sed to replace things and get rid of things, which was kind of complicated, to get rid of things and make sure we get rid of the right. We just want to know the right field, and we're going to number them. In other words, over here we got the wrong result. We didn't want to get that. We wanted to print, the certain fields. So awk is designed to deal with fields. So that means you have to have a field separator. So in a password file, the field separator would be a colon. So I can write, but the general format is awk minus F, field separator, and then C would be the actual separator. Then some kind of pattern, then an action, and then the files I want to work on. If not specified, the field separator is white space. each input is matched, each input line in a file is matched against the pattern and the associated action is performed. In other words, awk works line by line in the file. Whatever you'd want to do here, it's going to be per line. So we'll see some examples. Fields are represented by $n, n meaning a number. In other words, $6 would be the sixth field. And the field 0, the first field is $1. So what is field 0? It's the whole line. Here's an example. How do you read this? You read like this. Run awk with the field separator being a colon on the file PW, which stands for password, this password, PW file. And what are you going to do? The field separator is colon. And what are you going to do? If the third field, $number, remember $number means which field? If the third field is greater than 100, then print the third field. So given this file, so we didn't do it, but we're going to check what's the third field. The third field is 1, 2, 3. If this number is greater than 100, then print it. By the way, in this example, I gave you a password file with the actual encrypted passwords in it. But they're just made up. But that would be the way that would be an old-fashioned password file might look. Now another one, awk, where the field separator is colon. Okay, still a colon, that's good for passwords. Where $5, what's $5? What's $5, guys?
Username.
What?
The name of the user.
Right, the fifth field. 1, 2, 3, 4, 5. The name of the user. Where $5 does not contain, this symbol here means contain, does not contain the string Charlie. So it's gonna, that's the pattern. And what's the action? Print the third field, print the ID number. This small number, 100, 120, 139, 240, 2454. And in which file should you print this? On the password file. So if that was the password file, what's it going to do? It's going to, what do you tell me? What's it going to do? It's going to print the third field where the fifth field does not contain Charlie. So it prints this. Why does it print this?
Because all those users don't have Charlie in their name.
Exactly. Those users don't have Charlie in their name. And this is the third field. 1, 2, 3, 112. 139, 154. Okay. Use functions and or regular expressions. Print. So there's a function, there are functions built into awk, like print is a function and length is a function. Print the file means you buy a lot of paper. No. Print, so we have a special function called length. We already saw print, but length is the length of the fifth field. So if the fifth field is the name, so Charlie Brown, I guess, is 13 letters, Snoopy. These are the lengths of the field in the file PW. So that's a special function called length. There's more functions like that. Awk also can do things like this. This prints the third field of the line starting SNO. What's the file? What's the file again? So SNO is Snoopy, and the third field is his user ID.
How did you get Snoopy?
What?
You go back. Where was it? How did you get Snoopy? Why was it Snoopy again?
Well, here it's Snoopy because it starts SNO. And in this one,
we're
I
just
said
looking for SNO.
starts
Okay, I
SNO.
see.
print the third field. That's his user ID. So that's 139. Okay, more awk. There's some special variables in awk, built-in variables named NF, NR, and file name. There's some more, but those are the ones I want you to know. NF is the number of fields in a given row and number of fields. And NR is the ordinal current row number. So NR could tell me like how many rows there are in this file. Like in each time, the first line of the file will be NR will be 1. The second line of the file, NR will be 2. The third line of the file, NR will be 3. Now, the NF is the number of fields in that row. So the rows could be all the same number of fields, like a password file, but theoretically they could be different numbers of rows, number of fields in a given row. And I may not know the number of fields in any row. So NF is the variable that tells me the number of fields in a row. The file name is the name of the file. Why would I want the file name? Because, for example, I could write awk and then have a file and another file, and I print something and I want to know which file did it print that from? So I can print the file name. So what is this command going to do? Print where the field separator is colon, print the NF on the password with $1 in front of it. What is that going to do? Can anybody? Well, it says here. If the NF is the number of fields, so in other words, if there's 7 fields in the file, then $NF is the 7th field, the final field in the row. So this will print the final field for each row, and it will be independent of how many fields there are. If one row has 7 and one row has 3, so NF will be 7 and 3. So I'll always print the final field. What would happen if I just printed without the $? Then it would print 7 and 3. With the $, it'll print the actual 7th field and the 3rd field of the 2 rows that are in my file. Assuming my file has 2 rows and that one has 7 fields and one has 3 fields. Okay. Braces. As we have seen, the action to be performed for each line is placed within the braces. But we may want a certain action to occur only once, either at the beginning or the end of the processing of each file, of the processing of each file. In other words, we may want to set a counter to 0 or something at the beginning, and we may want to increment it during the processing. And then at the end, print done. For example, here, we can do like this. We have special keywords begin and end. We write like this: begin, and then print. What am I printing? The file name. Okay, print the file name. The file name could be either PW1 or PW2, because those are the 2 files. And I only do that once. I want to print that at the beginning. Then this is for every file. Now, it's going to print it for each beginning, because there's a beginning for this when it treats this file, and there's a new beginning when it treats this file. Just like there's a new end for each one of them too. So it's going to print the file name, PW1. Then it's going to check, is the 5th field equal to 10? Well, in our example, the 5th field probably not going to be 10. 1, 2, 3, 4, 5. It's probably not going to be the name is 10. But this is just an example. If the 5th field in the file is 10, then print, well, if $1 is the first field and $2 is the second field, what do you think $0 is? Can somebody guess?
Isn't $0 the name of the command?
In shell it is, but here in awk, it's the whole row. So it's saying like this: if the 5th field is 10, print the row. So it's going to print all the rows where the 5th field is equal to 10. And then at the end, it's going to print the word done. This will print the file name, then all the lines whose 5th field is 10, then the word done. It will do this for 2 files. Note the field separator here is default to whitespace. I didn't define this. A lot of times in the beginning, I'll define the field separator as being something, but here I didn't, and therefore it's space. What does this do? Awk field separator is colon, begin, set S to 0, and then this is the beginning, only the first braces. The second braces is for every row. Now for every row, do S equals S plus the third field and print. What is it going to print? Only at the end am I printing something. I'm printing one thing, one number. What is it? What is the meaning of that number? Hello? Everyone fell asleep? If you, Yitz, you there?
I'm still here. Yep.
You have any idea?
Nope.
Well, what's NR?
It's taking the average of something.
It's taking the average. NR is the number of rows. S is the sum divided by the number of rows. Every field, assuming that every field has a third field, every row is a third field. I'm going to add the third field together. S equals S plus, it's just like C++. S equals S plus the third field. So I'm going to take the average of the values of the third field and print that. You got that yet?
Kind of.
Which kind of? You know what NR is? Yitz? You know what NR is?
Not exactly.
Number of rows. You know what that means?
Yeah.
What does it mean?
I probably shouldn't have just jumped on that, but
Well, I told you a minute ago.
I'm assuming it's the number of rows of text in the file.
The number of rows in the file. So if there's 10 rows in the file, it's 10.
Mhm.
But, you know, by the way, I could do this class differently. If you guys want, I can just make very nicely defined videos for each field and put them on YouTube and not have an interactive class. Maybe that's better. And I can, then, you know, I'm not so tired and you're not so tired.
No, I like this better.
Okay, but you guys should be paying attention, or I guess you're going to rely on you. Anyway, so let's continue. We have another built-in variable in awk, which is FS, field separator. So up till now, we were using the field separator either by using the default, not defining it at all, which is 0, or we were defining it in this way, awk minus F, the field separator, and not defining it in the quotations. But we can also define it in the quotations like this. Awk without defining it, but then I say begin, and first the field separator, I'm going to change it to be a colon. And then, by the way, if you have two symbols here, what it means is either or. The field separator will be either a colon or a, you know, the letter Q, whichever you see first. If
You
the
need
fifth,
something in between. You write them like contiguously, like you don't write any separator between the different symbols.
that's right, just write colon Q, and it means either one. Yes, I believe that's the case. In other words, you can't have a field separator that's 2 letters long, as I understand it, as I remember. I mean, I didn't make a slide of that, so I might, I should probably. Anyway, this is 5. The fifth field does not contain brown, then print the last field. So again, if this is my file, There's a brown here and there's a brown here because it's his dog. So if it does not contain, it's going to print Sally and Smith, but it's not going to print Sally and Linus. It's going to print the last field. It's going to print TC shell twice. So again, if it does not contain, if the fifth field does not contain brown, then print the last field.
How does the field separator work again? It's looking at,
I have to decide what separates my fields. In this case, it's a colon.
so we're looking at the colons, it goes to the fifth field, and if there's no brown, if the name does not contain brown, then print something.
Then prints, exactly, then prints the last field. This prints the last field. Here I did a weird thing. I just defined the field separator as the number 2, and then I redefined it as the colon. Just to show you that that could happen. I could redefine it in the middle of my loop at some point. Notice this has a begin, but no end. It has a begin section, which I do once at the beginning, and then it has for every row do this, and then it has nothing to do at the end. That's fine. Here I have a begin and an end. Now I can do a loop. Look how I can do a loop. Remind you of anything?
For loop,
It looks like a for loop in what language?
C++.
Yeah. No, the only difference is the I doesn't have to be declared. I just use it. So begin, and I'm gonna only do this. Notice this is a really interesting example because there's just a begin. There's no middle and no end. So, and there's no file given. Well, I don't need a file because there's nothing. The middle relates to the file, right? The middle is what to do for each line of the file. But if I have no middle, then even if I would give a file, it would ignore it because I wouldn't do anything for each line of the file. I only do this thing at the beginning. Now the begin is only at the beginning. Well, so at the beginning, I'm going to do a for loop. And sometimes I don't have to do one thing at the beginning. I can do a loop at the beginning. So I do my loop 5 times and I print out I. So this program is just going to print out 1, 2, 3, 4. Well, yeah, I think it's going to print out 1, 2, 3, 4, 5. Something like that. And notice that this awk command only has a begin section. Could put a loop in any part. So here we have begin. Here we have a no begin and no end, just a middle. So this is for each line of the file. If the third field is greater than 100, then do the following. For every line, check the first field. And if the first field is 100, then while I is less than 2, so 2 times, print F I can do, like in C. Print F, and I can do string decimal. Which string and decimal? Fifth is the fifth field, that's a string, because it's the fifth field of my file, obviously a string. And the decimal is I. So I'm going to count 1, 0, 1, 0, 1. And then I plus plus. So it's
I understand what the S and D doing for the string and fit.
This is the way printf works. If you ever saw printf exists as a function in C. It also exists in C++ if you include the right library. But this is without parentheses. It's like a function, but without parentheses. So printf, and then I'm saying, don't print the letter S. That's what the ampersand, the percent sign means. The special character S, the special character D. So the S is actually means string. Print a string, print a decimal number, print a new line. Then after the printf function takes another parameter, comma, 5. So 5 will match to the S. The same order that I have here is the same order that I have in these parameters. So notice the command ends here with a semicolon. So I'm saying I is a decimal number printed in this location. And 5 is a string because it's the fifth field of the file. So print it with an S. S stands for string, string decimal. So it's like I'm telling it the format in which to print. F is like format, print format. Print it with a certain format. This is printed as a string. This is printed as a decimal. What to print as a string or decimal? This and this. This print as a string, this is a decimal. If I wanted to print first the decimal and then the string, I would just put a D and here and an S here, and then I'd have to switch the order over here. Because whatever order it tries to match that order. I wrote this has started to get a bit long for writing on the command line. Notice I have this function here, and it's kind of long to write that on the command line. So I could actually make an awk file, which has the shebang line similar to a bash file. But instead of specifying the bash location, I'll specify wherever awk is on my system. And then I'll do, all right, here's a shebang line. The shebang line is that line that starts with a pound. So I'll explain in the next slide. But here's a shell script. Not a shell script, a awk script and a file. This is a file. So it starts with the begin, and I define my field separator
What's the
as.
little F on the top in the shebang?
I think that means just that it's a file. It's designed to work with files. It's a flag for awk to tell it read the file. Because I guess otherwise it expects the first thing after it sees to be the command, not the file. But here I'm going to just have a file because the commands are all here. See, awk normally expects a pattern and then a file. Here I want to give it just a file because I'm going to give it a file. I'm going to give it a file to work on. And how is it going to work on it according to this file, according to this thing? So anyway, here's the colon. That's my field separator. And then I just print the third field. Very, very simple, but just to show you how to do something in a file. Now, here's how we run it. If we called this file awk1, then we'd pass the file pw into the awk command. And then it would run this thing, it would print the third field of this. Now you see, by making a file like this, I can run this anytime I want easily. I don't have to like have a command. I think it's hard to save command lines, but I can save a file. So in any scripting language, you need to specify where the interpreter that will be running your script is located. And any flags you want to pass the interpreter. We specify the interpreter in the first line of the script called the shebang line. If you leave out the shebang line, your shell will interpret the script. In other words, it won't be the shell will try to read your script, which is fine if it's a shell script, but it's not fine if it's an awk script. If you want to use awk to interpret your script and you know that your awk location is in bin, then your shebang line should look like this, bin awk with a -f. For bash, it should look like this, assuming that it should bin bash, assuming that it's in the bin directory. Here's another example of an awk command, an awk file. Notice this is a file, and it starts with the shebang. Whenever you see that it's starting with the shebang line, you know it's a file. So, and also it's on many lines, so it looks like a file. You begin, first define your, we tend to always do that, define your field separator. Otherwise, it'll be a space. The third field is 101. Then for I equals 0, as long as I is less than 2, I++, print the fifth field and the letter I. Or the number I, whatever I is. And you run it like this. Note the similarity to C++. One of the authors of awk helped create C++, or helped create C. Tov.
We're executing from a file that contains all this stuff, this awk.
Yeah, what we're running on the command line, we're just writing like this: awk1 arrow file. That's all we're writing on the command line. Now, assuming that this file exists, and assuming that awk1 1 is what I wrote here.
All right. And do we have to write anything specific to before the awk one to execute it?
No, as long as this is, no, as long as this is in, as long as dot is in your path, you may have to write dot slash to execute. You also have to make sure that awk1 is an executable file. Awk1 has to be executable, and it has to be that the current directory is in your path. All right, that's the end of lecture 4. I think, let me see what's the story with lecture. Sorry, lecture 3. Lecture 4.
Which lectures are referred to which labs?
We're still in the first 3 like I mean, which I can't map it up exactly.
The first lab, we haven't hit lab 2 yet, is what I'm asking.
We have. Lab 2 is we just hit it now.
We just did the scripting. Scripting.
The awk is lab 2.
Uh-huh.
Oh no, that's lab. That's a different thing. Where's lecture? I just want to see what lecture. Unix system lecture 4. That's what I want. I did. That was lab. Okay, what are we doing next? So yeah, let's save this for next time. Yeah. We'll save shell script for next time. What is Unix lecture 5? More. That's more of, yeah. So we'll save that for after Pesach, right? Well, next week we don't have class, am I correct?
Correct.